Yes, before we start, went ahead and graded all of the midterms. You should see the grades updated and Moodle. So the midterm, as stated on the syllabus, is 32% of your grade. So it makes quite a hefty contribution. And so, cool. So, yeah, so I went ahead and, all right, lost my train of thought. Okay, so midterm graded those, they're on Moodle. Cool. So additionally, the homework that I assigned last week is due today. So if you haven't turned that in, go ahead and turn that in to me, well, now. So, and besides for that, I think that is pretty much it. And so it's really all I have. So does anyone have any questions before I continue from last time? If not, let's go ahead and begin. So last time we were talking about, we started off this new chapter on graphs of sine and cosine, and we were talking about various characteristics that we can use to construct a one-period interval of the graph. So now what we're going to do is now incorporate translations as we scroll down a little bit further. So in the book, I want to say this is section 4.2 in the book. It probably is, but let's be safe. 4.2, yeah, 4.2. So if anything, preface this by saying this is 4.2 in the book. The homework doesn't seem that bad. It's only 4 problems. So what we're going to do in this section is pretty much continue from the last section. You're going to see a lot of material recycled over, but we're going to add translations. And in particular, it's going to be characteristics of shifting a function. So we talked about, well, what happens when, when you multiply a number in a certain position, how does that change the amplitude or the period, and how does that affect the interval values and the pieces and stuff like that? And all of that is still going to be prevalent in this section as well, but we are also going to introduce shifting a graph left or right, or also up and down. So I start off by talking about horizontal translations. So this is, so horizontal, say shift left or right. And this is whenever you add or subtract a number from the x variable directly. Now, those of you who just got out of college algebra, you might remember this. You might remember this from examples such as natural log of, say, x minus 2 or something, which means you would shift to the right 2 units, not the left. Remember, for left or right, it's the opposite direction. So notice a minus 2. If you're subtracting 2, then you go in the opposite direction, 2 units to the right. So this is a distinction you need to make moving forward. If you do a horizontal translation, the direction you go in is opposite to that of the sign. If you add 2, you go to the left 2. If you subtract 2, you go to the right 2. And I put another example down here where you're adding 3 to the x directly. Since you're adding 3, it means you go to the left 3 units. It's the opposite. This is a very common thing people will mess up on. And this is why I'm trying to emphasize it now, and even more so with the ensuing example problems that we shall look at. So now we have, for example, 1, y is equal to 2 sine of x minus pi over 2. So we're going to start off the same. start off the exact same. The amplitude, so it's been over the weekend, so let's have a quick refresher here. The amplitude, that's the number that multiplies the function directly. So it's going to be the absolute value of the number that multiplies the function. So absolute value of 2, which is just 2. So that was pretty easy. So that tells us what numbers go on the top and the bottom. Okay, so that starts off easy so far. Nothing really changes there. And then we move on to the period. So remember, this is affected by whatever number is multiplying x directly. There's nothing really multiplying x directly. So it's just by default 2 pi. Okay, so far so good. Nothing really seems to change. But we still move on to the pieces the same. So remember the pieces, drop down 2 pi, or whatever the period is, and you multiply it by 1/4. So we just get pi over 2. Don't give me an approximated answer. Pi over 2, not 1.7 whatever it comes out to be. That would be the pieces, which tells you that is the interval between each, or that is the displacement between each interval value. It's going to be pi over 2. So that's what it's saying. The difference between these two is pi over 2. The difference between these two is pi over 2. It tells you the stepping value. So that all starts off the same. However, instead of listing the intervals, we're going to now introduce the horizontal shift. We're now going to introduce this new thing. So everything starts off the same, but now instead of listing the intervals, we are going to instead first identify the horizontal shift. So this deals with whatever is adding or subtracting the x value directly. We have not had this before, but now we do. What is adding or subtracting the x directly? It's the pi over 2. So if anything, I'll put pi over 2. But now the question is, in which direction are we shifting? Left or right? And when it comes to horizontal shifting, it's the opposite of whatever the sign says. Subtract pi over 2 means you would shift to the right pi over 2. So to the right. So how does this change things? Now we've introduced a horizontal shift. So those of you who might have noticed that the period value is always the last value when you list out all the intervals, that is no longer the case. Because when we shift everything over in a certain direction, it's going to shift what that last value, in fact, it's going to shift every single interval value. In this case, it's going to take every interval value and add pi over 2 to it. So my way of denoting the intervals is now we're not going to start with 0. We're used to starting with 0 every time. Now we're going to start with pi over 2. Why pi over 2? That's the horizontal shift. This is why. It's not coming from the pieces. It just so happens that, in fact, let me just draw this down here so I have more room. One second. Just going to put this right here. Intervals. So the pi over 2 is not coming from the pieces. The pieces just so happen to be the same as the shift. That's just a coincidence. So we're starting off with not 0, but pi over 2. And now to that first value, we add the piece value. So in order to get to the next interval, we have to add pi over 2. So what's pi over 2 plus pi over 2? It's just pi. And then to get the next value, we have to add pi over 2. So I didn't really illustrate it like this before, but I just want to emphasize this is where the numbers are coming from. Now to pi, we add pi over 2. Or in other words, that's 1 plus 1 over 2, which would give you 3 pi over 2. Then to get the next one, you add pi over 2 again, because that's the piece value. So then you get 2 pi. Then we need one more. We need 5 in total. So pi over 2 is now added to 2 pi. That gives us 5 pi over 2. Because it's pretty much 2 plus 1/2, which is 5 pi over 2. Really should have done it like this. Plus pi over 2. I'm just rewriting the same thing. So then I can erase this so it doesn't get in the way of the graph. All right, cool. So that tells us the intervals. So we are not starting over here anymore because we're not starting at 0. Because we are shifting to the right. So the first value we start at is pi over 2. And then I'm just going to list out the values we found. Pi, 3 pi over 2, 2 pi, 5 pi over 2. So from here, well, we have our 5 intervals. Now we can go ahead and start to sketch out the shape of sine. Now, I'm going to detour from this right fast, just to remind everyone what sine looks like. So sine was the one where we drew the 5 dots like this. So sine always starts at the origin. Just in general, sine function starts at the origin. But we're going to be shifting this to the right. So that shape, let's keep that shape and that dot sequence in mind as we go down. So that dot sequence, it's not going to start here anymore because that's not our first interval value. It's not 0 anymore. Our first interval value was pi over 2. So now we start here. This makes sense because we shifted to the right. And then the sequence is up and back to the x-axis, and down here, then back to the x-axis. That would be a 1-period interval. And that's it. Yes, I do for the homework and for the, well, for the Unit 3 assessment, I do have in the syllabus that it is online. So I can't force anyone to come to class and take it, so it will remain online. With the online version, I am going to ask you to send me your scratch work for how you constructed the graphs. So for that scratch work and for your homework, I am expecting amplitude, period, pieces, horizontal shift, you know, stuff like that. I need to see that. I need to see your work.
I'm not very good at drawing the lines on the graph, but as long as it's labeled right, does that?
Yeah, in fact, this is a good way to draw because as you can see, mine looks good. And the reason I figured out how to get this right. So the way I do it, I've been getting better at it. Once you draw the dots, you're trying to draw arcs between them. So if you want to make them look nice, see, we're both right-handed. So I'll draw an arc from here to here. And an arc from here to here. And an arc also from here to here. Here to here. Makes it a little bit easier instead of just one fluent motion. That's the way I do it, and it's been coming out nice so far, which is great because I can't draw to save my life. But yeah, as long as, mainly I'm looking for those dots and some, I mean, if you did zigzags, I'd probably just comment, it's kind of lame looking, but I'll accept it for now. So that's pretty much all you get out of me. It's just a petty insult. All right, cool. So does anyone have any questions before we move on to just a similar example? Not? All right, let's get used to this idea of horizontal translation. We'll move on to example 2, much a similar problem, just a different function. So start off with the amplitude. So the amplitude, so the number multiplying the trigonometric function is -1. So it's really the absolute value of -1, which is +1. And the period, it's 2 pi divided by whatever is multiplying x, but there's nothing multiplying x. So we just write 2 pi. Pieces, it's going to be the same as before. It's pi over 2 because the period's the same, so the pieces is going to be the same. And then the horizontal shift. The horizontal shift here. So this is whatever is adding or subtracting to the x value directly. I think we can all see that it's pi, but in what direction? It's going to be to the left. Because when you add pi, remember, it's the opposite direction. Adding pi means you go to the left pi units. So we're not starting at 0. Whatever that initial point of 0 was, we now shift that to the left. So now we go on to the intervals.
There's a reflection.
Yeah, we'll get to that next. There is a reflection. So the intervals, so the first value we start off with, what is the first value?
pi2.
No. What's the first value I list in the interval?
The horizontal shift, -pi.
It's -pi. Start off with -pi. It would be 0, but we took 0 and we shifted it to the left. Let's see, I think relative to the people, I think relative to everyone viewing me right now, this would be to the left. So we're shifting 0 to the left pi units. What does it mean to go to the left? That's a negative direction, hence why there's a -pi. So the first interval is negative pi. And from here, in fact, I'm going to write this below so I don't coincide with any of the graph. So negative pi is our first value. So that's going to be the very first value we start off with. And I'm already going to go ahead and label it. The next value, guess what I have to add to it? I have to add the piece value, pi over 2. Yeah, it's negative pi over 2. That's the next value. And then I add another pi over 2, which is 0. Then I add yet another one. And then I add one more to just get pi. And there is a reflection as well. So at the very bottom here, I'll squeeze in reflection about the x-axis. And that is because the function is being multiplied by a negative. So there is a reflection. So that means whatever points that we would originally put, we just have to flip them about the horizontal axis, the x-axis. So now we need to figure out the point scheme. How do we trace the points for this graph? And let's go ahead and get a detour from this right fast. So for the cosine in general, start at the top, you work your way down to here, you go back up. So it's the cup-like shape. If you want to think of cosine in that regard, it's a cup-like shape. So, remembering that point scheme, we're back down here, and we need to remember that the point scheme has to not only be shifted to the left, but also needs to be reflected. So, I'm going to go ahead and trace out the points before the reflection. I'm going to do this in red. You don't have to do this. This would be without the reflection. So if this whole problem were the exact same, but we took out the negative in the front, this is what the scheme would look like. But instead, in black, I'm going to emphasize what the reflection would look like. So we flip every point about the x-axis. Also forgot the amplitude. There we go, amplitude. So now I'm going to get rid of the red dots. And now I'm just going to connect everything together. So it's an upside down cup because we reflect about the x-axis. So the upward facing cup is now shifted, or now flipped upside down, reflected rather. So notice this shape starts at negative pi, no longer starts at 0. Notice I built the graph for you in my notes, but when you do the homework, you will have to construct your own graph. It's convenient when I have a template here because I anticipate where the shift will happen at. I can draw an appropriate graph, but on your own notes, you will have to build your own graph and know that negative pi means wherever you draw your y-axis at, if you start at a negative value, it needs to start to the left of the y-axis. So things like that are important.
How many places you have to move it just depends on the pieces.
It depends on the pieces, yeah, how many negative pieces or negative interval values.
Yeah, it was shifted by pi, and then the pieces is pi over 2, so that's, 2 pieces.
Yeah, and I mean, you could see the difference between the first example and the second example. The first example, I didn't have any tick markers on the left side of the y-axis because I knew you were going to shift to the right. And then this example 2, I made a template to reflect that. I made 2 tick markers because there was going to be 2 negative interval values. But in general, if you're constructing this from scratch, you're not going to have those nice templates. So that's just something to keep in mind. So are there any questions about example 2? If not, let's move on to example 3. Now, there's a little bit more stuff thrown in. And let's go ahead and start off the same way as before with the amplitude. The amplitude is the absolute value of whatever is multiplying the function. That's just 3. So the amplitude is normally pretty straightforward. And let's move on to the period, which is no longer just 2 pi, because the period is affected by the number that multiplies the variable. We now have a number multiplying the variable. It's 2. Period is now 2 pi divided by 2, which is pi. Which means the pieces we drop down the period, multiply that by 1 over 4. We simply get pi over 4. Here's an interesting question. What is the horizontal shift?
Pi over 2 to the right.
No.
Is it pi? Because the 2.
I think you're just saying numbers and random things now. So this is kind of a trick question in a sense. A horizontal shift is denoted by what is adding or subtracting the x directly. Pi over 2 is not subtracting x directly. It's subtracting 2x. 2x is not x. So you might think, well, what gives? And what gives is the fact that 3 cosine 2x. So I know how much you all enjoy algebra. So I'm going to use a little bit of algebra to rewrite this problem, where I'm going to factor out the 2 from both of these terms. I factor out the 2. Like, you want to try your hand at this one? It's going to be x minus what?
Just so you're factoring that out. It's just pi, right?
Factoring out means you divide.
Divide, so it'd be pi over 4.
It's pi over 4. So to check your work, you can always just distribute back in. 2 times x is 2x, and 2 times negative pi over 4 is negative pi over 2. So you can always just do that to make sure you factor out correctly. But notice now we have a number subtracting the x directly. That's what a horizontal shift is. So notice the horizontal shift was not pi over 2 because pi over 2 was not subtracting just x. The mere existence of that 2 screws up everything. So we had to factor out the 2. And by doing it this way, now we see that the true horizontal shift is pi over 4 to the right. So that was definitely a tricky one. So that's how you find the horizontal shift if there is a number in front of the x directly, or multiplying the x directly. You have to factor it out to obtain the true horizontal shift. And then from here, we can state the intervals. Dennis, what's the first interval value we start off with?
Is it pi over 4?
It is pi over 4.
Jeopardy.
What's that?
Jeopardy now. Is it, what is?
What is pi
Yeah,
over 4?
question form.
What is pi over 4? This is a trick question. So to figure out the next one,
Pi over 4.
let me raise this up a little bit. I want to pi over 4, a little bit of space, so I can say plus pi over 4. Because remember, these pi over 4s that I'm denoting here are different pi over 4s. You might think, well, yeah, what is pi over 4? Exactly. One of the pi over 4s is the shift, and the other one is the pieces. These are two different values that happen to be the same. So what's pi over 4 plus pi over 4?
Pi over 2.
It is pi over 2. Last semester, people were very tempted to say that was pi over 8. It's not how fractions work. You add another pi over 4. So what's that one?
That's 3 pi.
It is 3 pi over 4. And then I'll just go ahead and finish it up. So we just keep adding pi over 4. So it's just increments of 1 over 4, and then you just throw pi in at the end. So that means our interval, we're not starting at 0. Not starting at 0. We're starting to the right over here at pi over 4, and then pi over 2. Pi over 4, pi, 5 pi over 4. So that means when we start tracing out the dots, we're going to start at pi over 4. Now this is a cosine function with no reflection, so it's going to be the cup. It's going to be the cup shape. So that means the cup will start here and not on the y-axis because we shifted to the right. This is not on the y-axis. And then let's trace a cup. Or with the dots makes it almost look like it almost makes it look like an absolute value graph, but it's not. So just like that. So that is us introducing the horizontal shift.
And now let's search something that says.
Oh yeah, you must have read ahead. Yeah, very good. So there's another So we were talking about left and right. What about if we want to go up and down? So great, the easiest thing to find, the amplitude.
What if we don't?
What's that?
What if we don't want to?
Well, I'll take a different class. Go take statistics. I haven't teaching this last year. Fine. Okay, so yeah, so we have to focus on vertical translation, which means up or down. So vertical translation, they shift up or down. So we did left or right, now we're going to do up or down, which means something as simple as finding the amplitude is now going to have a little bit of nuance to it. Because if the amplitude is 1 and -1, but then we start shifting up and down, well then guess what? The amplitude's not going to be 1 and -1 anymore. And you might notice by example 4 that, well, the template I provide definitely implies that there's going to be some vertical shifting of some sort. So that graph definitely does not look like the ones that I've drawn before. So with vertical translations, so the way to tell the difference, so going back to algebra, the way to tell the difference between a vertical shift versus a horizontal shift, or translation, a vertical translation is when you add or subtract the function as a whole. It's not when you add or subtract the x variable. It's when you add or subtract the function as a whole. So in general, the rule of thumb is adding or subtracting of any kind is a shift every time. Adding or subtracting a number instantly implies a shift of some kind, whether it's left, right, up, down. It's a shift. Now, what kind of shift? That's up to you to determine. I mean, here we're taking the cosine function and we're subtracting 3. So that's an example of what I mean. We are subtracting 3 from the whole function and not just the x variable. Just that analysis alone tells us that this will be a vertical shift up and down as opposed to left or right. Let's go ahead and actually do that. So start off with the amplitude. The amplitude is the absolute value of -2, because it's always the number that multiplies the trig function. So you would say, oh, it's 2, great, and I go to put 2 here, -2 here. Well, guess what? We're going to have to change that. Something as simple as finding the amplitude is no longer that easy now. Well, I mean, 2 is still the amplitude. That's not going to change.
That's just not where the peak and the...
That's right. It's not where the peak
graph is
and
gonna
the
be.
valley, I think they call it, the peak and the valley are going to be at. So now, immediately after amplitude, I think this is the best place to impose the vertical shift. Now to add even more nuance to this, does anyone want to take a crack at what the vertical shift is?
It's down 3.
It is down 3. So notice
It doesn't flip.
it's not opposite.
Yeah.
If it's -3 for up and down, you actually go down 3. I call it a verbatim shift. If it's -3, then you actually go down 3. You don't have to flip like you do with left or right. Normally the example I like to think of is a little bit of a tangent. When you have, a factorization like this, what do you say x is equal to? -1 and +2. You do the opposites. And there's kind of motivation here. So it's not 1 and -2, you flip the signs because they're being added or subtracted to the x directly. So it's kind of, there is more substance to this than just a rule of arbitration. Just, a bunch of math philosophers out there trying to overcomplicate things with these nebulous rules. There's actually a little bit of, consistency here. But tangent over. The vertical shift will be down
Haven't
3.
gotten to tangent yet. Still on sonic cosine.
Oh yeah, that's the next section. Could also talk about tangent lines. It's more of a calculus 1 topic, but that'd be kind of fun.
But that's not our class.
It could be. Just have to use a different textbook. That'd probably be an interesting appointment to my boss's office. All right, you're teaching Calc 1 in a trig class. Got bored.
That was too easy, boy.
Wanted to talk about McLaurin series because that was kind of cool. But anyway, so the vertical shift. So now we're going to get used to this process of amplitude, vertical shift, period, pieces, horizontal shift, and intervals. That will now be the official order that I will be expecting from now on. That is the order, and you'll see it very clearly in this problem, and was it the next 2 problems? Yes. So this is the official order now. I mean, you don't have to do it in this order, but this is what I recommend is the cleanest order. So now that we're shifting down 3, these amplitude values that we just found, guess what? They both go down 3. So 1, 2, 3. So what value is that? That's -1. And then 1, 2, 3. It's -5. So that's our new valley and peak values, lowest point and highest point. So I'm going to go ahead and erase the original amplitude. But that's where these numbers are coming from. So pretty much it's 2 minus 3 and -2 minus 3. It's plus or minus 2 minus 3. But you can also look at it as you take whatever the amplitude was, 2 and -2, and you shift them down 3. You can think about it either way. It really doesn't matter. So that's the new stuff. From there, everything else is going to continue as before. So the period, it's just going to be 2 pi because there's nothing multiplying the x. Pieces, drop down the period and multiply that by 1/4 to get pi over 2. We're going to look at the horizontal shift. I'm just going to start calling them VS and HS from now on, just a little bit cleaner. So the horizontal shift, what is it? Logan, what's the horizontal shift?
0. -0.
It's none. We don't shift to the left or right at all. There's no horizontal shift. We're not adding or subtracting anything to the x. So there's none. So that means we could just start at 0 because we don't shift at all. And so now we can move on to the intervals. We can start at 0 because there's no horizontal shift. And now we're going to just keep adding the piece value. So add, where's the piece? It's pi over 2. And we just keep going. It's pi, 3 pi over 2, 2 pi. And because there is no horizontal shift, that means that the last number will be the period. In general, the difference between the last number and the first number will always be the period. So that's the case in every problem. So the difference between, in example 3, the first number was pi over 4 and the last number was 5 pi over 4. Their difference is pi, which was the period. So that's in general how you can check to make sure that the intervals you listed are in fact consistent. And I'll emphasize that in the next 2 problems as well. But if anything, that tells us how to label these. And something I almost missed, reflection. Again, I'll just ruin it now and say we don't ever reflect about the y-axis. I just don't ask those problems. So we reflect about the x-axis. So whatever points that we have before, we have to flip all of them over the horizontal axis. So this is a cosine graph. This is the cup. But since this is a reflection, it's the upside down cup. So without the reflection, it's going to be exactly, this is without the reflection. Notice my dot is skipping the tick markers in between because I want it to be at -1, and then the center, the true center, because the horizontal axis also shifts down 3. So guess where the new center would be at? You go down 3. So that's why the center is aligned as such. That's why I'm skipping the in-between tick markers. So with the reflection, so notice this is no longer reflecting across the x-axis. So that's why the points will now be aligned as such. So I'm going to get rid of the old dots. So now it's the upside down cup, in other words. And let's just go ahead and illustrate that. I wonder if other schools are hiring. That would be nice. But we get an upside down cup. Just like that. And this would be the graph. And so the next 2 problems are just going to slowly incorporate everything together and just see how we can handle it. Does anyone have any questions about example 4? All right. With example 5, this seems to have a lot going on. Okay. So example 5's got a lot going on. So let's start. Okay, so what's the amplitude? It's a good question. What is the amplitude?
Is it 1?
It is 1.
Because there's nothing from the cosine.
Yeah, there's nothing multiplying the cosine. And in fact, I'm going to preface this now. This problem is intentionally written in a different way. You might be more comfortable with a slightly modified way of writing it. Not plus. This might be more comfortable. All I did was just switch the trig function and the number in the very front. Because a lot of people will think that -5/2 is the amplitude. It's not, because it is actually subtracting the graph, even if it says plus.
And they just already factored it out for us, basically.
What's that?
It's already factored out for us too.
And they already factored out the 3 for us, so that was nice of them. So really, we can write it like this, because I like to enclose the cosine, what's in the cosine. So the amplitude, once we slightly rewrite everything, it's clear to see that the amplitude is 1. Technically absolute value of 1, which is 1. So it might look a little bit weird. I'm going to put 1 here, -1 down here. I'm just putting these for now. We will have to change them, or shift. I'm going to put them as the second tick marker from the x-axis. The reason why we will immediately see with the vertical shift. So what is the vertical shift here?
5/2.
So 5/2, what direction?
Is X 5 and Y 2?
It's x5 and y2. So let's try that again. What is the vertical shift? Courtney?
It's 5/2.
5/2 down.
It's down 5/2. It's down 5/2. Because you are subtracting 5/2. They're just trying to throw you off by making it a fraction. But you're going down 5/2 because we are subtracting 5/2 from the function as a whole. So that means 1 and -1 are now going to be shifted down 5/2, which is also 2.5. So that's why I have, really these increments are going by 1/2, because I anticipated that we're shifting down where we have to consider half increments as well. So if we take 1 here and we shift it down 5/2, well, what is 1 and we shift it down 5/2? 1 minus 5 divided by 2. It's -3/2, which is all the way down here. So that's down 5/2 units. Then what about -1? What is -1 shifted down 5/2 units? It's -7/2. So that's 3/2, 4/2, 5/2, 6/2, 7/2. It's merely a subtraction. It's down 5/2, which means take the original amplitude boundaries and you're subtracting them by 5/2. So that's why I went in half increments. That's why these tick markers are half increments. Again, when you construct your own graph, whatever the problem may be, you'll have to figure it out on your own. You won't have these templates that I provide. Some way to convey the values that you find. So I'm going to go ahead and erase the original amplitude values. These are going to represent our peak and valley values. Okay, let's keep going. So the next one is the period. Rebecca, what's the period? one more thing. There is technically something, yeah, there's technically something multiplying the x. So the 3 is multiplying the x. So it kind of goes in the reverse order of before everything was multiplied in, and we had to factor out the 3. But we factored out the 2 in this problem, but the 2 still contributed towards our period. In this problem, the 3 is multiplying to the x. So that 3 and the x. Because if you just distributed the 3 back in, you would see it a little bit more explicitly. So that one was a little tricky. But I just wanted everyone to see that. Okay, so let's move on to the pieces. So you take the period, multiply that by 1/4. So I'm going to try and redeem yourself.
Pi/6.
Pi/6, yeah, that looks good. Pi/6. So it's just 2/3 times 1/4. 2 in the 4, get a 2 down here, and it's just pi/6. All right, cool. Pi/6. So if anything, we know what the size between each interval will be. Okay, and let's look at the horizontal shift. Horizontal shift. Well, this is the good thing about how the problem is formatted to us. They already factored out the 3 for us. So because of that, we can immediately see the horizontal shift. We can immediately see it. To the right, pi/6 units. Because remember, for left or right, it's the opposite direction. -6 means to the right 6. So that tells us the first interval value to start off at. So right pi/6 is positive pi/6. This will put this over here. So pi/6, and so we add to that the piece value, which is just so happens to be pi/6. So that's pi/6, and pi/6 plus pi/6 is pi/3. Plus another pi/6. It's going to be pi/2. Plus another pi/6. It's 2 pi/3, or yeah, 3. Yeah. And then one more. So that's 5 pi/6. Does everyone see where these numbers are coming from? 1/6 plus 1/6 is 2/6, which is 1/3. 1/3 plus 1/6 is 3/6, which is 1/2, and blah, blah, blah. So we know what to put as our interval values. 2 pi/3, 5 pi/6. And so finally, we have a lot of cosine shapes here. Cosine tells us that it's the cup, and there's no reflection. So that means we start at the top. The middle is going to be this value right here, which is -5/2. That is our final shape. Does anyone have any questions about this one? Because if not, I think example 6 would be a good final problem for everyone to try on their own. So you go ahead and scroll down. Here's your template. You don't have the notes printed. Try to figure out how these numbers contribute to this, and go from there.
Yeah, I'll go back to that. Should I go ahead and start talking about it, or do you all like a little bit of time? Well, if you want a hint, I do have a hint written up there. probably the more friendly approach of looking at the problem, is by rewriting it in that way. So that may make some of your numbers a little bit more easy, a little bit easier to determine.
Where did you get pi over 2 for when we changed it?
So when I factored out the 2, what you're doing is you're dividing 2 out of each term you're factoring out of. So since one of them is pi, you're dividing 2 out of that, which gives you the pi over 2.
Okay.
Another way you can check it to make sure you factored it out correctly, to go the opposite direction, you distribute. So then you have 2 times x, which would give you the 2x you had before. And then 2 times pi over 2, well, the 2's cancel, you just get pi.
Okay.
It's a good way to check to make sure you factored out correctly. So I think this is a good time to bring everything back together. So amplitude is positive 2, and the vertical shift is up 4. Hopefully that part is okay. So instead of having 2 and negative 2, let's see, I think I did these, yeah, so I think I did these in increments of 2.
Yeah.
So before it would be 2 and negative 2. Again, you can construct it as you please, but we would shift both of these up 4, which means 2 gets shifted up to 6. Negative 2 gets shifted up to 2. So if anything, now the new bounds are going to be 6 and 2 with a center of 4. Because you start at 0 originally, and if you shift that up 4, then you end up at 4. So it tells us where the center of those dots, when we lay out all the dots, it tells us where the center will be at. So if anything, we have this for the y-axis. So what's the period? It is just pi. Because you would say, all right, 2 pi, unless there's something multiplying to the x. There is. It's a 2. You divide by 2, and you get pi. So we drop that down to help us find the pieces. So pi times 1 over 4, pi over 4. And it tells us what to add to each interval value. But in order to figure out where to start, we need to figure out the horizontal shift. So the horizontal shift is, so Dennis, what did you say the horizontal shift was?
Oh, left pi.
It is to the left, wait, left who?
Pi.
Pi, no.
It's actually pi over 2 because you have to factor it out.
Yes, that's where this factorization comes into play. I almost agreed with you there. You almost got me. So that's the reason why I factored it out like this, because then you see what truly is adding to the x variable directly. That's the only reason why I did that.
So the horizontal shift, it will always be what's in parentheses, either like left of pi 2, or if it was a negative, be right pi 2.
Yes,
Okay.
that sounds right. So So this tells us where we start at for the interval values. So the first interval value is going to be negative pi over 2, because we go to the left pi over 2. So it's negative pi over 2. And then to get to the next one, we have to add pi over 4. So pi over 4 is the piece value. So negative pi over 2 plus pi over 4 is negative pi over 4. And 0, pi over 4, pi over 2. This is a sine function, which means that it's not going to be one of the cup shapes, but instead it's going to start at the center, go upwards, and then go downwards, unless there's a reflection, which there is. So there's a reflection. There's a reflection about the x-axis. Now, we can go ahead and plot everything. So I'll go ahead and plot it as if there was not a reflection. So I'll do this in red. So if there was not a reflection, it would start here, because we shifted up by 4. And then it would go up here, back down to here, here, back up to here. So this would be the dot sequence for sine without the reflection. But with the reflection, every point gets reflected about the center. I can get rid of these red dots now. And you don't have to do that if you don't want to. And that would be the graph.
The reflection's kind of tricky.
Yeah, it's thinking, you're thinking there's all this stuff going on. There's every shift and every kind of nuance whatsoever. And then a reflection, really?
Well, I was thinking like that was 4 minus 2 sine, so I didn't know if that negative like went with the 2, to make it a reflection or not.
Yeah, it does in this case. Yeah, but that's what makes this one a tough problem. That's why it's definitely last, because it's got a little of everything. So with the last 2 minutes, so perfect timing. Goodness, I write great notes. That's perfect timing. Okay, so with that being said, naturally, I'm going to ask for this homework for Thursday. 4 problems. And yeah, as I mentioned, the section is 4.2 in the book for 4 problems. And yeah, that's pretty much all I have. Don't have any questions? Have a good day.